This video is covering question 5, part D of the 2022 AP Calculus AB free response section, no calculator allowed. So question D here is, it's kind of nice. They didn't used to be this nice on the test, but they're kind of telling you exactly what to do then you just got to do it. I mean, there's the hard part, but they're telling us to use the separation of variables to find an equation y equals f of x using the particular solution with the initial condition f of 1 equals 2 and using the differential equation, the derivative that they gave us back at the beginning here to start. So what this is this is an initial value problem. So this is going to be an antiderivative problem, and we're going to use that specific point 1, 2 there to find that plus c value that we always get when we're doing integrals. They tell us that they want us to separate this out, right? Like I said, they didn't used to be this nice to tell you that that's what you need to do on something like this. But here they're telling us kind of how to start this problem off. When we go to undo this derivative, in order to do that, we need to break this up into the y side of the equation on one side and the x side of the equation on the other. So the first thing we're going to want to do is we're going to want to move this dx out of the bottom and over onto this right hand side there. And then we're going to want to move this square root of y plus 7. We want to get all the y pieces over to the other side. So we would essentially multiply both sides by the square root of y plus 7. Cleaning this thing up now, what we would be looking at is on the left now, those dx's would cancel, and so we have 1 over the square root of y plus 7, and then we've got our dy still sitting there, and that's going to equal 1/2 the sine of pi over 2x, and then square root of y plus 7 cancels with our square root of y plus 7, and then we have our dx over here. From there, now that we've got it separated up, now what we can do is we can take the integral of both sides. Because now these both have the dy and the dx that they need, we're going to take the antiderivative on both sides of this function. The left side of this, as we look through it, so it's really two integral problems in one. So as we look at the left side over here, the left side is going to require us to do a u substitution. So we'll run a u substitution on this left side. So when I do a u substitution, it's the same set of steps every single time. Step 1 of the process is I need to choose my u. And when I do that, I kind of have a priority list that I've developed. The first thing I look for if it's available would be a natural log if it's in the function. If that's not there, the second thing I would go looking for is what I call the inside piece, as if I was doing a chain rule problem, the part of the function that's inside another function. And if that's not there, I'm generally going to look for the bottom of a fraction. And then overall, what I usually want to find is I'm really looking to find the piece that has the highest power of x, or I guess in this case, the highest power of y. So going through my list here, I don't have a natural log, so I wouldn't want to choose that. The next thing, the inside piece, I do have an inside piece. Y plus 7 is inside that square root there. So u is going to equal y plus 7. Then step 2 of the process on a u substitution is always the same. I need to take the derivative of that u. So this would be du, and because we're talking y's, this would be dy. Taking the derivative of y following the power rule, I'd bring the 1 down, subtract 1 from the power would give me y to the 0, so that equals 1. Then the derivative of a constant is always 0. From there, I now need to solve to get dy by itself. When I go to substitute back in, I need this full equation over here to now be talking the language of u. And that includes changing that dy into a du. So to do that, what we'll do is we'll solve this step 2 equation to get dy by itself. And so this one's pretty straightforward because all I need to do here is multiply the left side by dy, multiply the right side by dy. I cancel that dy out, and I get du equals dy. So now that I'm here, after I'm done with step 3, now comes the substitution part of this problem. I'm going to take u and substitute it in, and I'm going to take my du dy piece and substitute it in. So how you do this is just work your way left to right through the integral, and it's either one of the things that you're substituting in or it gets left alone. So working through this, I'm going to end up with 1 over the square root, and then all of that now is u on the bottom, and then dy is now going to become du. You just want to keep working one side at a time, right? Let's not do multiple things at once. So right here, this is what I call your reward for all your hard work, a brand new math problem. So we treat this as its own little integral problem right now, and we solve that. Well, to do that, as soon as I see a root in a problem, that's a rewrite that I need to do. So there's a handful of rewrites that we always want to be on the lookout for. The first one is whenever I've got x to some power inside a root, I'm going to rewrite that as x to the power over the root. The second one that I always want to be on the lookout for is whenever I've got a number over x to a power, I want to rewrite that by bringing the x up from the bottom to the top and making that power negative. And so what we have going on this one is actually both of those rewrites in one. We would start, I'm just going to kind of do some of this work over on the side here. We would start by doing the first rewrite on the root. That's a power of 1 over a root of 2. So then that would have been u to the 1/2. That would have been the first rewrite. Then I need to bring that from the bottom up to the top. So then I would have used the second rewrite and made that u to the negative 1/2. So we do a double rewrite here. So this is going to be rewritten as u to the negative 1/2 du. Now that we're there, now we're ready to apply our power rule. So we would add 1 to the power and divide by that new power. So we add 1 to the power, that's going to be u to the 1/2, divide by that new power. And then when you're doing these problems, normally you would want to put a plus c there, right? Well, because we're doing two integrals, we're really going to have a singular plus c. And the best place to put that plus c is going to be over on the right-hand side. You could technically put it on either side, but I recommend using it on the x side on the right side of the equals. So from there, I would go ahead and do two things to finish this problem off. I would flip and multiply by this 1/2, so that's really going to be 2 times, and then remember, we didn't really care about u, we cared about what u was, and so you're going to plug your u back in. So we plug back in y plus 7. So that is the left side of our equals. If you kind of think about this equals moving down the row here with us, that's the left side. Now we come and look at our antiderivative on the right side. Over on the right side, we have the antiderivative of basically just sine. This is a special case antiderivative, one you just have to have memorized. If I have the antiderivative of the sine of a number times x, this is the best way to remember it, is with a number on the inside with that x. It's going to save you from having to do a second u substitution. The antiderivative on this will be 1 over, negative 1 over, whatever that number on the inside is, and then sine came from cosine. So here, the 1/2 up in front is going to come along for the ride. Then I'm going to multiply that by 1 over my a value. So the a value here is pi over 2. So this will be negative 1 over pi over 2. And then the antiderivative of sine was cosine, and we leave the rest of that inside there. And here's where I want to apply that plus c value. Now, again, you only have one plus c, so let's put it on the right-hand side always. Now, I just need to kind of clean up some of this algebra. I'm going to flip this pi over 2 back up. So this is going to end up being the negative from the top gets us negative 2 over pi cosine of pi over 2x plus c. That 2 cancels with that 2, and we're left with negative 1 over pi times the cosine of pi over 2x plus c. And then we got done a little bit early on this one, so I'm just going to pull this down here and set those two things equal to each other. So we took our antiderivative on the left side, we took our antiderivative on the right side. So now what we have to do is, because they wanted the particular solution, that means find the plus c. We're going to use the point they gave us here. That's an x value, and that's a y value. So I know when I plug in 1 and 2 that I'm going to have to then, I can solve to get my c value by itself. So we come in, this is kind of a new portion, so now I plug in 2 for y and 1 for x, and we get out what we get out. So we'll get 2 times, instead of y, I'm going to plug in 2 plus 7 to the 1/2 equals negative 1 over pi, and then this will be the cosine of pi over 2, and instead of x, I'm going to plug in what x is, which was 1, plus c. So from here, I get on this left-hand side, I get 2, and then this would be 9 to the 1/2 equals, this is the cosine of pi over 2. The cosine of pi over 2 is going to be coming from our unit circle. Pi over 2 is up top here. This is the point 0, 1. And then the x and the y values always come from the sine and the cosine value. The x value is the cosine value. The y value is the sine value. So the cosine of pi over 2, I have the cosine of pi over 2, which means I want the x value from here. So that's going to be 0, which is always awesome when you're trying to solve for c. So I get 0 plus c. 9 to the 1/2, remember the 1/2 power, that came from a root. You know, that's one of those ones you better know really well. So if I have 9 to the 1/2, that is a power of 1 and a root of 2. That's the square root of 9. The 1/2 power is something you really should know is representing a square root. So that's 3. So then we get 2 times 3 equals c. So out of there we end up with c is going to equal 6. So now that we have our c value, now we can go ahead and plug that back into our equation up here. So we're going to take that and we're going to plug it into this equation right here. And what we always end up having to do at the end of this whole process is then solve this equation to get y by itself. They want a y equals at the end of all of this. So I plug back in my 6 for c inside here. So I get 2 y plus 7 to the 1/2 equals negative 1 over pi cosine of pi over 2x, and then my c value, I know what that is, that's my plus 6. So here we're just going to start solving this thing to get y by itself. So the first thing I'm going to do is I'm going to get rid of the 2. I want to isolate that 1/2 power, that square root. So over here, I'm going to multiply everything by 1/2. So that's going to come into each of these pieces. They'll cancel out on this side. We'll get y plus 7 to the 1/2 equals, multiplying this 1/2 up into the front here, I'm really just multiplying it by this negative 1 over pi. So that's going to be negative 1 over 2 pi cosine of pi over 2x, and then 1/2 times 6 is going to give me a positive 3. Then to cancel out that 1/2 power, I am going to square everything, right? That's a square root. I'm undoing the square root by squaring everything. You also can see that you're getting this to be a first power. Powers to powers is a multiply game. So I end up with y plus 7 equals all this stuff here. Boom, 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 plus 3, all of that squared. And then the last move on this is going to be to get that y by itself. I'm just going to minus this 7 over to the other side. And so I'm running out of space here, so I'll put the final answer. On the left-hand side, y is going to be left alone. The 7s are going to cancel out. I have all of this stuff up in front minus 7. So this is going to be negative 1 over 2 pi cosine of pi over 2x plus 3 squared, and all of that minus 7. And so that is my particular solution. That's the final part of my answer. So in the end, question 5, part D here is actually 5 out of the 9 points for this whole problem. So they don't normally put such a point heavy piece. They kind of like to split it up 2s and 3s through the entire 4 pieces. But on this one, what you're going to get out of here is you're going to get 1 point for setting up this integral properly at this point. You're going to end up with 1 point each for getting each of your different antiderivatives, the left side and the right side here. That's going to be 1 point. So there's 3 points. Then you're going to end up getting a 4th point for figuring out your constant there, that plus c value. And point number 5 comes at the end by getting the whole thing put together. So Not a horrible problem, but definitely a lot of work in a lot of little places where dropping one negative sign kind of turns you sideways in the end. But 5 points in total, not that bad. Separate it out, 2 integrals. Keep the plus c, 1 plus c for the whole thing on the right-hand side. Find that c value, solve for y. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.